An essential skill, which involves capturing data with Explorer and carrying out numerical integration with Excel to estimate total volumes of flow from a watershed. We need to start by going to a home page, type in www.usgs.gov, which will take us to the US Geological Survey's home page. From there, we go to the lower left-hand corner to select the option to look at water. This brings up a page called Water Data for the Nation. We select Water Data for the Nation. And we'll find that we now have the option to look for individual states in the drop-down menu in the middle of the left-hand side of the page. Let's choose Nevada. Now that we're in Nevada, let's select Current Conditions. With current conditions selected, we want to go to Streamflow Real-Time Table. This is organized by basin. So when we click on this, we find that we can scroll down through this menu to the Pyramid Lake and Winnemucca Basin, where we'll find the Hunter Creek Gauging Station. These are listed by number with hot links by number. So when we get there, we're going to go next to the Hunter Creek title and click on the Hunter Creek Gauging Station number in Pyramid and Winnemucca Lakes Basin. It is here. Click on that, which will bring up the home page for the Hunter Creek Gauging Station maintained by the US Geological Survey. Once that appears, we have a lot of information available to us. But let's start only by looking at the time series daily data. This is going to give us an average daily flow rate in cubic feet per second for a period that we'll specify in a minute. From the drop-down menu, we specify time series daily data. Now, we scroll down further and we specify that we want our output in a tab-separated file. We're getting these data for water year 2011, which means that we need to start, our begin date is 10/01/2010, and our end date then will be 9/30/2011. And this will give us a table that we can then use, that we can import directly into Excel. And the procedure for that is fairly straightforward, but involves several steps. So here we're specifying our end date, again, end of the water year, 2011, 09/30. Which will then bring up our tab-separated data set. We click Go, and this is our tab-separated data set. The steps to bring this into Excel, again, are several from here. Not complicated, but important to know so that we don't end up with a lot of data that are difficult to use. Our next steps then involve 3 steps to bring the data in so that we can do the numerical integration. We begin by importing the data from the website. First step, and a very important one, is to copy the URL for the report that we have in this table. So we highlight it and hit Control-C. That puts it in memory. Now we right-click in the middle of the data set with our mouse and select Export to Excel. We'll end up with an error message that looks like this one. Here is where we paste in our URL using Control-V. Hit OK. We'll receive a selection of data to import. Click on the small arrow in the upper right-hand corner of that screen, and the entire data set, after we click OK, will be imported into cell A1 of our spreadsheet. Now we have all of the data separated into 5 columns. At least 3 of these columns are columns. In fact, some of the data in the first 2 columns, and all the data in the first 2 columns, are really essentially not useful. So let's select it and then delete it. Delete both columns, A and B. Then let's also select the rows that are now empty and delete those. Finally, there's one more column that we can delete. It's the set of notes. Now these notes are very important actually because the US Geological Survey is telling about the quality of their data. For the purposes of this though, let's assume that the data are okay and that we're preparing now to carry out the numerical integration with the data that we have given to us and that we've imported into a spreadsheet. So now we have date in column A and flow rate in cubic feet per second in column B. Let's carry out the numerical integration with Excel. Here, it's a very simple process. We have 365 values in column B, each representing a daily flow rate in cubic feet per second. This is the average daily flow rate in cubic feet per second. In order to carry out the numerical integration, we have to multiply each one by a constant to estimate the total volume that came out daily at that flow rate from our watershed. An easy way to do this is to simply sum up all of the flow values here by selecting the bottommost cell, going to the home key at the top, and selecting the summation tool and simply hitting return and summing up all of the data values above, and then multiplying that times our constant, which transforms cubic feet per second to cubic feet per day. It's the same thing as having done that for every value from 1 to 365. Here I'm typing in the value, and we'll end up then with a total amount of flow expressed in cubic feet that occurred over the course of our entire water year 2011. So that's the entire process. It involves capturing data, bringing them to Excel, and then carrying out the calculations in order to do numerical integration.